To understand what an average rate of change is and how to calculate it, let's start with an example. Suppose the temperature outside is 42 degrees Fahrenheit at 4 p.m. and 35 degrees Fahrenheit at 11 p.m. How much did the temperature change on average over that period? We don't need any fancy math to answer this question. To calculate the average rate of change in temperature from 4 p.m. to 11 p.m., we simply need to calculate the ratio of the change in temperature to the change in time. The change in temperature, which I'm calling delta capital T, is 35 degrees Fahrenheit minus 42 degrees Fahrenheit. The change in time is 11 p.m. minus 4 p.m. 35 degrees Fahrenheit minus 42 degrees Fahrenheit is negative 7 degrees Fahrenheit. And 11 p.m. minus 4 p.m., that's 7 hours. So this simplifies to negative 1 degree per hour. A few things worth noting about this process. First, in math, we use the Greek letter capital delta to indicate change, which is why I wrote delta capital T for the change in temperature and delta lowercase t for the change in time. Second, our answer came out negative because the temperature was lower at 11 p.m. than it was at 4 p.m. In general, negative rates of change indicate a decrease, and positive rates of change indicate an increase. Third, the units of the two changes dictate the units of the rate of change. In this example, the temperatures were measured in degrees, and I chose to measure the time in hours, so the result was a rate of change with units of degrees per hour. It is very important to include units for problems like this, because I could have also chosen to measure time in minutes or days, and that would have changed the numerical value of my answer. If I don't communicate what units I'm working with, no one will know what my answer actually means. Finally, just because the average rate of change was negative 1 degree per hour doesn't mean that the temperature decreased by 1 degree every hour. It is quite possible that the temperature was constant for multiple hours or even went up at times, but the overall change over the full 7 hours was that it dropped 7 degrees. We can generalize this process to find an average rate of change for any function y equals f of x over an interval x equals x1 to x equals x2 as follows. The average rate of change in y equals f of x with respect to x from x equals x1 to x equals x2 is given by the ratio delta y over delta x, which is equal to f of x2 minus f of x1 over x2 minus x1. Remembering that f of x1 and f of x2, those are the outputs, those are the y values. So when we subtract them, we get the change in y, which we're calling delta y. And that if we subtract the x values, we get the change in x, which we're calling delta x. If this reminds you of the slope formula, m equals y2 minus y1 over x2 minus x1, you're right. This is the exact same process. And in fact, the direct connection between slopes and rates of change is a crucial concept in calculus. We've seen one example of calculating an average rate of change from a function described in words. Next, we'll look at how to calculate average rates of change from functions given by graphs, tables, and formulas.